Okay. So,
in like 3 months ago. So
hmm. So you have a valid
wait, do I have to
IP.
start a timer?
Oh, sure, sure. Yeah, start a timer.
Okay, hold on. I'm gonna mute myself so you can't hear me chewing while you're trying to focus.
Okay. Okay.
Okay, I'll start timer in three, two, one.
Okay, so the problem is valid IP addresses exactly four integers separated by single dots, okay? And 0255 leading zeros. We want to return any possible valid IP addresses that could be formed by inserting dots into S. You cannot reorder or remove any of the digits. And you must return the valid IP address in any order. Okay, that makes sense. So four integers separated by single dots and between 0 and 255. Okay, this one isn't because it's not four digits. Uh, yeah, these aren't and these aren't. This one has an at symbol because that yeah you can't have that. Okay. Oh, but it only contains only digits. Okay, I see. Okay. Um, and you may return the addresses at any time. Okay. Okay, so that makes sense. So what I'm thinking of is given like a string as containing only digits, we have to do basically figure out every single possible combination. And then what I'm thinking of that we can do is we can have a pointer starting at 0, and then we can either make the decision to insert a dot or not insert a dot. Now, there's a couple of criteria which we'll have to immediately terminate if there can't be like a if it'll be an invalid IP address. Um since it says it'll only contain digits, we actually don't have to account for that. So we can just keep it. We'll just assume that it's all going to be numbers. It cannot have a leading zero. Okay, so let's just write this down. Cannot have leading zero. Um, four digits each, and then okay, so on and so forth. So what are the possible combinations that can be done? Let's see. Four digits separated by single dots. Hmm. Okay, so I see. So just to clarify, like given like a like a crazy amount of numbers like this, you're saying to basically do all possible IP addresses that are like inside, right? So like it could be like this, it can be like this, it can be this, assuming you insert dots, but it can be any of those, right? Is that correct?
Hold on, I think I mean like paste an example.
Okay.
It's not like um, it's more like okay, so give it something like this. I mean, I guess technically thing works, but then you want that.
Oh, I see. So you're given 255 1135. Oh, okay, okay, I see, I see.
The string length has to be less than 20.
Oh, okay, that makes sense. Less than 20. So the constraint length less than 20. And then also, I'm noticing for this one, it says here that it consists of exactly four integers separated by single dots. Oh, okay, I see. So we have one, two, three, four. Oh, okay, 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 right, right. So it has to be less than 255. So for something, okay, something like this, yeah, you're right. You can just add like this, this, and this, or you can move it and like have this. Okay, that makes sense. Hmm. Well, okay. Um, so what I'm thinking of is that this is a permutations problem, wherein we have a certain amount of dots where we can place it. We can place the um, like in between the numbers. So in order to figure out the different permutations, we have to basically adhere to the criteria where it cannot have any leading zeros. It has to be four digits. Uh, yeah, four not four digits, but four integers each. And then we also have to make it less than a 255, right? What I'm thinking of doing is we can start off with a pointer, and then we have to determine at every single given possible area, right? We have 255, like basically, we start off with like this at the beginning. And then we have to decide whether or not we can add a possible valid IP address. So for example, for this one, well, you can't add it for this one, you can either choose to add like a dot here. Yeah, you can choose to add a dot here, and then you can move on, and then you can choose to add a dot here, right? You move on, you can choose to add a dot here, so on and so forth, and we'll have this at the very end, right? But this isn't valid because this exceeds 255, so then it would evaluate to false. So an idea that I'm thinking of is basically doing a permutation where you make the decision to either add a dot or not add a dot at a given point. So we can basically create a tree of basically at a given point we can make the decision add dot or not add dot. So for this one, we can choose to be like, okay, like we want to add the dot to 2, right? Or sorry. We can choose to add the dot to 2. So it'll eventually look something like this. 2 dot that, and then we have 3 dots left, and then we keep going on and so forth until basically you construct the entire tree. And at the very end of constructing this entire tree, we can do a check to see whether or not, oh, does it have a leading 0? Does it have 4 integers each? And is it less than 255? If so, we append it to a valid result array, and then we'll be able to determine any valid IP addresses through there. Does this seem like a valid solution that I can begin implementing?
This looks good.
Okay, sounds good. I'll
Must be
begin.
the implementation, buddy.
Okay, okay. I'll begin the implementation now. So we'll have like a def. I don't know. We'll call it IP address, and then we're given a couple of variables. We're given the IP address, and then as well as that. Oh no, sorry. We're given the string, or we'll call it S actually. We'll call it S, and then nice. That's all we're given actually. So we'll go ahead and do this. We'll do a DFS. We'll make another internal function called DFS, and then actually we can just put this outside. But given this, we want to call DFS on the initial string. So the parameters that we're given with the DFS is we first of all we want remaining dots left. So we can have this remaining dots. That's our first variable we want. And our second one is where our current position is in the actual permutation itself. So we can go ahead and do curve pause. Yeah, let's say that for now. Yeah. And then with the current position, so what we're gonna do is we first want to call DFS with a current position at index 0, and then we also want to have our remaining dots, and we know that at the very beginning before remaining dots. Now from here, okay, we can just return this value at the very end. From here, when we have our current position, what we want to do is we want to check and see, first of all, we want to make the decision to insert the dot or not insert the dot. So we'll say we'll have like a current string. Maybe, yeah, we'll have a current string where, oh, okay, actually we need to put this DFS, well, we don't need to, but I'm going to put this DFS method inside the IP address so we can access the string over here. So what we want to do is given the string, we want to figure out the current position, but we want to basically make the decision to insert at the current position or not. So we want to construct a new string. Yeah, we want to construct a new string saying like, oh, like we're going to insert a dot in here. So let's think about this. If we insert a new string in the middle of, let's say like this, right? You're effectively constructing an entirely like a new string because it's going to be an over n operation to modify that string. So for every single time we modify it, it's going to be O of n because it's an array. So yeah, we might have to think about that because we want it to be time efficient, and we want it to we want to be able to insert the dot without having it be time inefficient. So, okay. Before we think about that, let's just code the rest of the template out for the backtracking, where we have the remaining dots over here, and we want to basically, we'll have like a result string. Actually, yeah. So what we can do is we can have a resulting string at the very beginning of the DFS, and then we can choose to add. We can either choose to add like a dot or not add a dot. So we can do res dot append. Yeah, well, actually we'll do res plus equal the current position, so string at the current position, and then along with that what we're going to do is we're going to also want to add the dot. So res plus equals the dot. Okay, now, so the one thing we want to check here is, okay, in order to make sure that it's effective, we also want to make sure that the numbers, like the numbers in between, like the previous dot and now, is less than 255. So we can do a check to see whether or not that works. And we can do that by just checking to see, basically the current sequence. We can have a current sequence variable. Okay, wait, let's see. So with the result, we're going to append it, and then we can either choose to add the dot and then move on forward, and then, or we could choose not to add the dot. So, okay. So we add the string at the current position, and then we add the dot. And then we can choose to either, we can choose to do a DFS. Oh, okay. I see where this is going. So instead of having a current position, what we should do instead is have a current string instead, which contains like our current string that we've iterated through so far. So at the very beginning, instead of this, we can have a basically an empty string, and then we can have the numbers which are remaining for us to go through. So if we have like this, for example, yeah, remaining, you can have like the string as the remaining, and then so we can pass this in, and then this is basically going to be our bucket. The very the very first string in the sequence is going to be what we can use, what we know we can also add along as we're going through the basically the DFS. So we start off in our current string. We can add the string at the current position, or we can add the string, adding it at the 0th index if it exists, right? So if s still exists, then we can add whatever's at the very beginning, and then we can either choose to add the dot or not add the dot. And we know whether or not to choose the dot by first being able to grab all, like, we have to convert what the result is right now and check if it's less than 255. So if the length, or if like the integer equivalent of the string, so of the current string from the beginning to the current one, yeah. So yeah, so if the basically if the integer equivalent of the current string is less than 255, then what we want to do is we can add the dot, and then we can keep going forward calling the DFS on the remaining one. So we can do a DFS on the current string, and then we can do the remaining dots subtracted by 1, and then we'll have our remaining string. And our remaining string, we want it to be, we want to remove the very first one because we've added this scenario. So we want to do from 1 to the end of the string, pretty much. So, yeah. Something we also we've got to watch out for is for something in the middle. So let's say for example, this one, we want it to end where there's a dot because we only want to check this number to see if it's less than 255. So, I have to think about this. We have current string, and then we want to check we have a current string, and we have remaining dots minus 1 from 1 to that. We can have another, So what I was thinking is of having another value which contains only up until like the previous dot, but then yeah. So what I'm thinking of is I'll have like another parameter. So like instead of current string, you'll have current number, and current number will only contain up until like what like the next dot is, right? So if we add a dot, then we only want to be continuing with like basically an empty sequence, right? And then we can check to see whether or not that's equal. So I'll go ahead and try that out. I'm a little hesitant on doing that because it means you have to keep track of another variable, but I'll code it up and then begin seeing how it goes. So we have a current string, and then we'll have our current number. With our current number, what we're going to do is we're gonna start it off at like just an empty string again, and then we have our remaining dots and then s minus 1. So with our current number, it's going to be equal to this, and then for this one we also want to do current number plus equal s0 because we're adding that onto it, and then we're checking to see what the equivalent is. So at the very end of this, you check to see if it's less than 255, we add the dot, and we do the DFS, and then what we want to actually do is we want to remove the DFS, like the adding of the dot to the current string. Oh, yeah. We want to remove the adding of the dot to the current string, and then we want to do another DFS with our current string, and then with basically a new copy. Oh, actually, we don't want it to be a new copy. We want it to keep on going with our current number that we're on. So we have current number again, and then we have remaining dots subtracted by 1, and then we have our remaining bucket, which is 1 to here. So this is what I'm talking about when I said we have two different areas. We can either choose the path if it's less than 255, the integer equivalent, we add the dot and we do the DFS. Otherwise, we just add it and we keep moving on to the next number. Yeah. And then at the very end, we want to have a base case. So we want to have a scenario where there's going to be no values left, and then we want to check to see if it's a valid one. And for this one, there's a criteria. It cannot have a leading 0. Okay, wait. Actually, this is for every single integer. Right. So, like for example, so for this one, if it's like 192 and this becomes 190, it's no longer valid, right? Because it doesn't matter. Okay. Is that correct?
Wait, say that again.
Like if you have like 190 and then you remove it and make it if you have like 190, this becomes instantly invalid, right?
Wait, why?
Because it cannot have a leading 0.
Oh, you just can't have one like this, or not like that, like this.
Oh, you mean at the beginning? Okay.
Or they can have one like that. You can have one like that.
Okay, that makes sense. Yeah. Okay.
So like this example, you can't have this.
Right.
This.
Okay.
Fun.
Okay, I see. So in order to check for that.
Also, how come you're adding another dot here?
Oh, sorry.
Or do you mean
I want to remove it. Yeah. Good catch.
Okay.
Yeah. So we remove the dot here, and then also check for leading zeros. We only want to do the DFS if the string if the string at the current area is, if the next string, we only wanna be able to do this if string 1 and string, okay, we only want to add an extra dot if only string 1, so the next item in the sequence is not equal to 0, right? So not equal to 0, because let's say, like, for example, you're here and you're gonna add your dot in the next sequence. This is a number that's like, oh, less than or equal to 255, and then you check to see, okay, we can add a dot here, but is the next one going to be a 0? You do that by accessing S1. If it is, and you don't do it, etc., etc. Yeah, and just to check the sheet, let's make sure that this works for the very first iteration. We have a current string, and then we have our current number, which is equal to an empty string as well. Yeah, and then we have this. We have S0. It becomes, we add the 0, so that becomes a trailing. Yeah, that becomes a trailing 0, and then. Oh, okay. I see. So we also need to have a check to see whether or not the very first iteration is equal to 0. So if, yeah, so we, like, for example, in a scenario like this, we wouldn't want to add the 0 at the very beginning, right? Because that's, yeah, because like this won't be able to catch that. So in order to do that, we can do a check to see. Maybe this isn't like a good way of doing it. Instead of doing this, we can do it to check. We can check to see if the current string. Yeah, so we'll do a DFS, and then we can check to see if S, and then if the string exists, and then if we add this, and then we have if current string 0 is going to be equal to if current string, or sorry, current number is equal to 0, if current number 0 is equal to 0, then we know that it's not a valid number. So we want to make sure that we're not able to, that we shouldn't have this return as a valid IP address. So we actually want to catch this in the next scenario. Like we want to catch it here, right? We want to prevent this from ever happening. Okay. And so, yeah. I just need to figure out how to avoid having a 0 at the very beginning of like the very first number, because this should work for every other thing except for the first combination. We actually, let's just do like a quick check for that at the very beginning. So if S0 is equal to like a 0, then we can return DFS. Same thing like this for, and then yeah, DFS 4, and then we have like a S, except this time we start off at 1 we start off 1 extra, so it avoids the 0. Yeah. Actually, if there's a 0 at the very beginning, this can't be done regardless, so you have to return false, right? Like, oh, like
no, it can be done. It can be done. Like you can have something like this.
Oh, right. Wait, what? You can have this?
You can't have a leading 0 if it's part of another number, but you can have a 0 by itself.
Oh, I see. So you can have a 0 by itself. This is dastardly. Okay. Well, that would have been nice to know. Okay, anyways. I just...
Dude, it was in the example.
Yeah, my bad, bro. Something I gotta catch. Okay. But... Okay, yeah, so... Now that we avoided all of that... Yeah. That okay. if if there's nothing left in the string, so if string is equal to nothing left, right? Or yeah, we want to check this actually inside here. Yeah. Or actually, yeah. If string, if the next string is equal to nothing left, okay, let's just say if the string is equal to nothing left, then what we want to do is we want to return like the basically check to see if it's a valid IP address, and it should be if it's reached all the way this way. So then we can add that to result. So we can do we can have a result array, res equals this, and then we can do res dot appends the current string here, and then we can return that at the very end. So we should actually do this, and then return res at the very end. Now, the issue with this one is that you need to basically there might be like an error because if you're trying to grab something that doesn't exist, if you're trying to grab it from one ahead, but then like there's nothing left in the string, then it might return an error. Okay, so actually instead we could do this. If s1 like this is equal to an empty string, if there's nothing left, that's when we can just do append, and then we can just do a break here. Yeah. And then we can also complete the equivalent for this DFS over here. Yeah. Yeah, so because this we want this, actually we can put this here. If s1 is this and that, we can append it and we can just break it. So that way there won't be some sort of exception error over there. So let's just run it through with an example just to see like how this is. Oh, what time are we at, by the way?
27 minutes.
Okay. So let's say we have this one again. We start off at the very beginning. We start off with 255, 255, 111, 35. We start off and then we have an empty string for our cur string. And then we have our cur number. And then we have our meeting dots. Oh, we subtract that. Then we we do. And then we have the string, which is we subtract it also. So string is equal to this, right? So basically, we can either make the decision to add 2, and then we can have 2 as part of our current number, and then it resets, right? So we can choose to add like a 2, and then the second we add a dot, it'll choose to reset, and then it'll go to like this, and then we'll have like a 2 dot at the very beginning here. And then basically we can keep on building this up until the very end, subtracting the remaining dots as we go along, and slowly moving this forward. So like the string is slowly being removed at every single given point. So yeah, yeah. So I think this is my final solution.
Wait, hold on. Oh, it's cut off my screen. Okay. I think this should be 3. You only have 3 dots. You have 4 numbers.
Oh. Okay.
This one, you shouldn't subtract if you're not adding a dot.
Oh, yeah, you're right.
Yeah, let me see if it works.
Okay.
A moment of truth, buddy.
Oh, my.
Shoot. I think the way I did it is very different, so I don't know.
How did you do it?
I didn't do each I didn't do like, you know how you're like adding a dot and then subtracting dot like 1 digit at a time?
Yeah.
I just did like in groups of 3. So I do like add 1, 2, or 3 digits, and then I'd add a dot after all of them. So then like you get all the combinations of 1s and 3s. But
Oh,
if you're subtracting a dot, it might be okay. Wait, I think. Wait, are you missing a case where? Wait, what happens if you reach here, but you still have dots?
Well,
Because then
oh,
you'll
you're
have
right,
something.
you're right. Um, or, or like this, right?
Y-
Like
yeah, something like
if it equals 0, you have to terminate it, and at the very ends, or if like there's no more stuff left.
yeah. Uh, Stupid indentation errors. This one should be a return instead of a break.
Oh, right.
But do they get you to run it in Tesla or just explain?
No idea. I should actually ask that. Oh, let me ask that. But
Wait, there's no subtract equals operator for strings.
what?
Yeah, I've
Okay.
never seen that before though. I realize I've never seen that before.
But there's a plus equals.
Yeah, there is, but there isn't a minus equals, I don't think.
Oh,
Let me
I'm
search it up.
stupid. No, I'm stupid. I'm stupid. I just do this. Equals
Just do like
curve
the
string
indexing.
like 1 to
Yeah.
like a length curve string like -1 like that, right? Wait, no, so like this.
Yeah. Wait. Yeah, yeah, like that. Yeah, I'm taking that. Okay. Uh,
That's not good. That's not good. What does it say?
uh, this is the outfit.
What the? Am I not subtracting it?
This in case isn't now, but you need a way to stop the. You need to stop the. You need to stop the branch if it's reached like a certain number of dots and hasn't reached the end of the string.
But I'm
Because right now you're only
subtracting it.
stop. You're
Oh yeah.
no. Like see how like if you add these ones, you
Yeah.
add like three dots, but then
Yeah.
you keep it's because it's not how do I explain it? Like like
What the? What's going on
generated
here?
10 billion strings.
Oh my. Wait, what?
Holy. Oh wait, wait, how many is this? Let me get a full screen. Okay, I won't even load on my leak code because it's too
That's
many.
crazy.
Oh, I copied it. Let's wait. Let me wait,
Wait,
I'm
I
scared.
thought
It's
it's
gonna
just
like
subtracted by
lag out.
1. No.
Oh, that's all of it. That's all of it. All right. Oh wait, what?
How come? What?
Let's see.
Why am I not adding that? What's going on here? Does this work? Like the part where I move the dot afterward, is that why?
Mm, wait, length string minus one.
How do you remove the last? I'm gonna search this up.
I've never seen it done like this. Like, I never removed something from a
Oh,
string.
it's
Because
dot
aren't the strings
pop.
immutable?
I'm so stupid.
Wait, but you can also do that. I'm pretty sure
You can also do it.
the indexing. Actually, I don't know though. Like if it says pop, but if it gives us the same like messed up stuff, then
Try it
pop
again.
doesn't work either.
Does pop work?
It's not something to do with that. Then let me try. String has no object pop.
Oh wait, no. Oh, or you can do this. Or you can do this. Hold up. Like this. Like this. Like this.
Okay. Oh yeah, I think that's what it's the same thing.
The same thing. Oh,
Yeah, it generated like 10 billion.
Dude, what? Where? Dude, I am removing the dots though. Right?
Mm, wait, unless you're passing the wait, you're passing the curse string in.
Hmm.
Maybe if you okay, what happens if you because we don't want to remove it on the last one though. But the last one shouldn't cause an error because you're just
Yeah.
adding the letter.
Yeah.
So mm,
Wait, there's no comma, Josh.
where?
In the def DFS, there's no comma.
Oh yeah, I added one
Oh,
in the
okay,
code.
okay.
It wouldn't even run if you didn't have a comment.
Yeah, I was like, what the?
Is it because wait, what can your the S thing be?
My ass?
Because can't S like
Oh,
if
dude,
you
I'm
know you're
not.
just going through the whole thing,
Wait, I'm not
S can be
adding.
a dot.
Huh?
Can S be a dot? Like S1.
Huh. Wait, what do you mean can S be a dot? Like,
Because you passed in the whole string, right?
I pass
Like
in
your
what's the meaning
curse
of the string.
what's your curse string plus equals S0? There's dots in the string.
No, no, there's no dots in the string. It's just like an integer, right?
Oh yeah, that's true. Dude, what were you saying before that?
No, no, I was just gonna say there could be like a naming conflict because like IP address has an S and then def DFS has an S too. But then like the inside takes more precedence, right? So
Yeah, I don't think that's it. Wait. Uh, res dot append. Wait, there's nothing that wait, how come where's this like thing that was uh stops it if the dots are zero?
it says if remaining dots equals 0, right?
Yeah, but what happens if like what if you have something like is a one a valid IP address if you just have like a bunch of one digit numbers?
What do you mean like this?
Like you're given this, right?
Mm-hmm.
What happens if it's just like and it gives you back like
This isn't valid. Oh
you're
no,
saying like this is but like where does it catch that?
like this one, you mean?
Where does it like not add this?
Wait, wait, what's wrong with this one?
Because it didn't use all the digits. Like no, like say you're given this and then it's like in the middle of doing
Oh,
this.
I see what you mean. Like that.
I don't think that's it, but
What? Oh yeah, yeah. What? What you mean? Are you serious? Let's see.
no, like okay, wait, I got string index out of range now
What?
for this one.
String index out of range? Oh, wait a minute. No, wait. Which line? This line?
Well, wait, hold on.
Oh, yeah. Thanks.
Wait, Okay, if you switch it back to 4, it does add this thing.
It does add it. Okay, that's bad.
You need a way to stop. You need a way to stop this one.
So
But
the
if you,
way for
if you switch it to and, then you get a string index out of range for. Let me double check which line.
this is crazy. What kind of interview is
This one.
this?
This one.
Oh,
It's because you solved it like I guess like it's kind of also like a people would try and solve it this way.
I solved it
I
like
think
in
I
a
did it
funky
weird.
way.
Oh no, I think it's. I actually think your way is more common than mine. I don't even know if I solved it properly. Like, oh, it obviously works, but like I don't know if I like if the proper way.
Uh, oh, not S1. So there's no S1 here. Oh, right. No, no, no. I know what this is. If uh S add 1 is equal to an empty string, then you just want to return also because that'll get rid of the index error.
Okay, let's try this.
That's like putting a band-aid on though.
Bro has like the ugliest four if statements I've ever seen.
Oh.
Okay, now this is the result. It's like getting a little bit better.
Bruh.
Oh, oh my.
Wait,
There's not
what?
many though.
Oh, I know what's wrong. I know what's wrong.
Oh, it's because now you're adding like too many. You need
Yeah.
a way to stop it if it's past 3.
Mm. And then
You need to break it if cur string is greater than 3
yeah,
or cur number. Well, I don't even know what cur number. Oh, cur string is like just the index, right?
yeah. Or if like like string if the remaining string. Okay, hold up. We can do this. And string remaining. Wait a minute. Wait a minute.
What?
Wait, hold on. I'm just thinking right now. Like if this is like if the string remaining is equal to 0. Oh, okay, I see what you mean. So like if the current number is greater than like 4, is less than 2 to 5.
No, greater than 3. Like if the length is greater than 3. Wait, what is the current number again? That's like the 3 digits you're on, right? Or the
Yeah,
2 digits you're on?
that's the 2 digits you're on, yeah.
It is a string, right? It's a string.
Yeah. But then I'm thinking like if I add like a string here, right, on DFS, and then it goes to the next sequence, you don't know what these numbers are. This is what's remaining, right? This is what S should be.
The current number is like 5 then, like right at that point.
Yeah, the current number should be no, like it resets. Like here it resets back to nothing again, right?
And then what happens in the bottom one though? It continues, right?
Yeah, at the bottom one it
Because
keeps.
the bottom one
Oh,
is the
the
bottom one's
bottom
where
one
it's
is what's
happening.
catching the error. Oh yeah, you're right. You're right. Yeah, okay. So then like so well,
Oh,
if
bro is so silly.
dude, stop. If current number
45 minutes, buddy. This is the
like
ugliest code I've ever seen.
shut up. Okay,
Dude,
like
do not write this in the interview.
Stop.
5 if statements.
stop. If length of the current number is less than like oh sorry, if it's greater or equal to like 3, right? Wait, even if if it's greater than 3, then we want to return.
No, if it's 4, 3 is valid, right? Wait, no, because you're adding? Wait, what?
But oh, I meant greater than 3. You can do also like greater than 4 also, it doesn't matter, but
No, like, isn't if it's equal to 3, it's valid?
oh yeah, you're right, yeah. Yeah.
Okay.
Wait, no, sorry, wait, and no. Actually, there's a better way of doing this. If the length of or like if the integer version of the current number is greater than 255, greater or equal to 255, that's more valid. Then your turn. Right.
Okay.
Then you do like res. Wait, sorry. Then you do res
Okay.
dot. This is right,
Wait, no,
right?
you don't want to add it
Oh, okay, you don't want to add. Okay.
because then you're gonna add like this shit with like 4 digits.
Okay, fair point. Okay, yeah.
Okay, let me 515.
This is crazy.
Oh my.
It doesn't work, right?
Oh my. Now the output is empty.
It's empty.
It's empty list.
No. Oh wait. Oh. I know why. I know why. I know why.
Dude, it seems like you know it all the time. Why? Then why don't you
Oh.
put it right the first
Oh.
time?
Oh. No.
Okay, good, good.
No.
That's what I was looking for.
Oh yeah. Oh man.
Okay.
Doesn't
Okay.
work.
2 cases left.
I'm actually gonna shoot someone. What's wrong with this, bro?
Dude, also you're checking it as the one is equal to the numbers here.
The what?
You're checking if S1 is equal to the number 0. Isn't S1 a string?
Here we go. Well,
Dude, interview's over at this point. You got any questions?
dude, it's already past 45. I already lost.
It's the only one case past this.
Oh man.
It's like 2 base cases.
Hmm.
So I keep track of the index, the size of like the like basically it's like the size of how many numbers are in there. So it's like it's equal to 4. That means you have like 4 IP addresses or 4 digits. So it's a valid IP address.
Wait, what's the size? The
Like it's the number of digits separated by dots there are. So if it's 4, then that means you have a valid IP address. If I is at the end of the string, so that means you've included all the numbers.
Okay, right, no.
So in that case, you want to add,
Mm.
and then I think for this one, if the size is greater than 4, so you add. So if it's like something like remember we had before where it's like all of them
No.
are just separated by dots, like 1 digit numbers.
No.
Then you'd return and stop that branch.
Mm.
Or if you reach the end of the string and you only have like 3 numbers because your numbers are too big, like this or something, like you have too many of these, then that would
No.
break the recursion.
No.
And then the last step is kind of weird. It's like, so basically I do it in like a group of 1s, 2s, and 3s. So that's why it's range 1 to 4. And then basically I just add a 1, 2, and 3 to like the current index, and then I'll just add a dot after immediately, as long as there's no leading zeros and it's greater and it's less than or equal to 255.
Oh, I kind of see it. Yeah.
Basically, and then yeah, so basically if it's like this is like my current string is, I don't know, like 2, 5, 5, and then like I'm here, then I'll add like I'll do that as one branch, and then I'll do like this as another branch, and then I'll do like this as like another branch, and then I just like, let's say it's not the last one, so let's say like it's like this. So this is like the current string, and then I'll just add a dot on here, add a dot on here, and add dot here, and then like continue recursion.
So like basically okay. I think like what you're saying. So like, sorry, like for like this. Like you're either choosing to go forward like once, you choosing to go forward twice, and you choosing to go
Or
forward three
3 times.
times before adding
Yeah,
the dot. And you do
because
like a for loop for
yeah,
that. Okay, I see.
and then I add a dot after all of them. So like I add a dot, and then I'll call another like recursion. So I'll go 3 more branches on this one. So it could either be like 1, like another 2, or then it could be like
Yeah.
and like that,
Mm.
and then it'll just keep going, like on all the branches. And then it only like if, for example, you get to like here or something, then this one will trigger base case, so it'll cancel it.
Yeah.
And then if you had another one, like if this is valid, like this is if they're like at the last index in the string, so that's what this one checks. Then we can just add it, and then yeah, that's basically how it works.
Oh, and this is the leading zero one, right?
This is the so this captures the leading zeros.
Yeah.
So it's like when you added so if j is greater than 1, so because remember you can have a 0 by itself, so if it's just like this, then it's
Yeah.
valid. But if you can't,
No.
you check j is greater than 1, and then the first thing you're adding here is 0, then it's invalid. So you don't want to trigger this backtrack on it.
Right. And then, like J.
And
So I is
wait,
where
why
you.
am I?
I is where you
I don't know
are.
why I'm adding. Wait, hold on.
Mm.
What am I adding? Why am I adding 1 here? What
Wait,
was I
where?
thinking there?
Where?
For the res.
Well,
How
you're
come I didn't
appending
add just
the
1?
address except one more, right?
Wait, isn't res the whole number? Like this? Res is like, we want to add like this whole thing, right?
Oh, wait, what? Sorry. Say again.
Or like this is the address, right?
This is the address.
Yeah, so how come I'm adding 1? Like starting at the second index.
Maybe I have no idea. Maybe.
Address dot. Oh, I know why. It's because on the first backtrack I added a dot at the front, just like this. So
Wait,
then I
what?
want to add like I only want to add this part.
Wait, why did you add a dot? Oh, cause
Oh,
yeah,
I add a dot before every. Oh, okay, I'm stupid. Yeah, I got it.
yeah.
I haven't seen this in 3 months, so like then I'm trying to make sense of why I did that. And then I
Yeah.
was like,
So
oh, that's a smart play.
I think the difference between yours and mine is that instead of like adding the dot individually from this way, you do it all the way up until 1 to 4, right? That's like the big difference.
Yeah.
Yeah. And then
Oh, baby. I don't think this question is that easy. Like, I
yeah.
don't think it was super hard, but I don't think it's like